What is going on, guys? Welcome back for another video. So in this video, we're gonna take a look at how we can use TensorFlow TextLineDataset to be able to load our own custom text datasets that we might be working with for our project. So let me show you the dataset that we're mainly gonna work with in this video. So this dataset, by the way, if you're familiar, is a sentiment analysis dataset where we get a movie review and we're supposed to tell if the review is positive or negative. All right, so for example, in this case, we have, once again, Mr. Costner has dragged out a movie for far longer than necessary, and then it goes on. Then we also have a column for the label, if it's negative or a positive review. And then we have if it belongs to the test set or the training set. One thing to keep in mind here is that this dataset actually has unsupervised reviews as well. So that is one thing that we're gonna keep in mind when we're cleaning and filtering this dataset to be able to use it for. So one thing I do want to say is that every data is going to be differently structured. But I think that showing you how to deal with this dataset in particular using TextLineDataset is going to give you an understanding of dealing with text data that extends to many different kinds of dataset. I'm also at the end of the video going to show you a couple of ideas of what to do when dealing with datasets that aren't structured in a similar fashion as this one. So let's get started. All right, so let's start with creating a TextLine dataset. So we're gonna do ds_train is tf.data.textLineDataset. And we're gonna send in that IMDB.csv file that we just took a look at. And then as you saw, this file right here is going to contain the examples both for the training and the test set. So what we can do is we can create another one, test to be tf.data.textLineDataset of imdb.csv. imdb.csv and then end quotes. So what we're going to do here is, for example, for the ds_train, we're going to try to filter out all of the examples that belongs to the test set. And then the opposite for the test set, we're going to try to filter out all that belongs to the training set. So before doing anything, it might be good to just know that this works. So we're going to do for line in ds_train, and we're going to print line. All right, and if we do this, it's going to print every line sequentially. So what we might not want to do that. So what we can do is we can do, first of all, .skip1. This is going to skip the one that sort of the first row, which describes all of the columns. And then we can do .take, and we're just going to do .take5. So that means that we're going to just take 5 examples. So let's look at so let's run that and see how it looks like. So as you can see, we get the first example, or yeah, index 0, 1, and then we get the review right here. We get the test set, and then we get that's a negative review. So what we want here is this right here. We want this, and we can get it. We can get that by doing printf.strings.split that line, and then we can do a separated by a comma. It's essentially going to split the line by a comma, and in this case, it's actually going to split the review as well. So what we could do to avoid that is we could send in an argument right here to be max split equals 4. So it's going to split this one, this one, this one, this one, and then it's going to split all the rest, which is the review, just once. So it's not going to continue splitting the review. So we can rerun that and see how it looks like. And as we can see here, now it's doing that on a single line. All right, so what we want here, first of all, is the test set, right? And that would be the first index here. So the thing we're gonna do is we're gonna create a function, and we're gonna call it filter train, and we're gonna send in one line. And the first thing we're gonna do is we're gonna split line, and we're gonna do tf_strings.split line, and we're gonna split it by a comma, and then we can send in that max split equals 4. So then we can first of all see what is the belonging of that particular example. So we could call it dataset belonging. So this is either going to be training or test set. So we're gonna do that by split line index 1. But then we can also get the sentiment category, which is split line of index 2. So this is either going to be positive, negative, or it's going to be unsupervised. And we don't want the unsupervised ones to be in our data set. And so we're going to filter based on these two right here. And the dataset belonging can be train or test, as we saw previously. All right. So what we're going to do here is we're just going to return true. Let's see, we can do it like this. Return true. True if dataset belonging is equal to train, and if the sentiment category is not unsupervised. All right, then that's an example that we want to have in our DS train. So then if it's not, we're going to return false. So what we can do here then is we can do dot filter, and we can send it through this filter function, which we just called filter train. So if we would now do the same thing, we're calling DS train again, we can see right here that we're just obtaining the ones that belong to the training set. And that's exactly what we want for the DS train. So what we want to do now is we want to have an identical one for the test set. So we're just going to call it filter test. And then the rest should be exactly the same, except this should be test right there. And then we're going to do the same thing on a test set, filter, and then we're going to send it through filter test. All right, so one thing here is that you might actually want to do this beforehand. So you might want to just split them into two different CSV files so that you would have, for example, train.csv and then test.csv. And in this way, you're going to save on some compute by not having to filter the examples sort of when you're actually training the model. But you might need to use this filter function for something else. So it's good to know that it exists and how to use it. So now that we've actually done that, what we want to do is we want to, let's see if we can make some kind of to-do list. So we want to, first of all, we want to create some kind of vocabulary, right? If we're going to send this into our model, we want to create a vocabulary, first of all. And I've shown how to do this in a previous video in TensorFlow, covering TensorFlow dataset, but I'm going to show it again because I think it's very valuable and could help you out. So then when we've created the vocabulary, we want to be able to numericalize your text string, sort of the text string to indices, right? And we're going to use token, let's see if it's TokenTextEncoder, I believe it's called. Let me check that. Yeah, so it's called TokenTextEncoder. That's going to do that for us. And then lastly, we're going to use, we want to pad the batches so we can send in to an RNN, for example. All right, so that's sort of what we want to do now. And to be able to create the vocabulary, we first want to have a tokenizer. And there are a couple of different tokenizers. The one I'm going to use is tokenizer TensorFlow datasets, TFDS, .features.text.tokenizer. And we're going to create a function. So we're going to call build vocabulary. And so the tokenizer is going to split a sentence. So let's say I have a sentence, I love banana. Then that's going to split it into a list with I love banana. All right. And then that's going to then be able to get tokenized, that's going to be able to be numericalized. That's our step 2 to something like the index for this particular word in our vocabulary. So that's, let's say we just have those 3 words. Maybe that would be 0, 1, and 2. And then this is something that can be sent into our RNN later on. So for the building of the vocabulary, we're going to send in some dataset and maybe DS train. So we're going to send in DS train. We're going to send in some threshold. And we're going to send in some threshold because we want, if this word occurs this many times, then we want to include it in our dataset. And in this case, we're going to choose, I don't know, let's say 200. This is going to be dependent on the dataset, but let's just choose 200 because it's a relatively large dataset. And also there are different ways to build the vocabulary. And you can imagine doing this in multiple ways, and I'm perhaps showing you a more simple one. So first of all, what we're going to need is frequencies. which is going to be just a dictionary. Then we're going to do vocabulary, and we're going to do a set. And first of all, we're going to do vocabulary.update, and we're going to send in some start token. All right, start of sentence token, and that's just what we call it in this example. And then we have vocabulary.update, and we have end of sentence, right? So EOS for end of sentence, and then token. So we want to have those in our vocabulary. And then we're going to do for line in ds train.skip of 1. So we're going to skip the first row, and we're going to do split line tf strings.split line comma, and then max split equals 4. Then we're going to obtain the text or the review, and we're going to do that by split line of index 4. Then we're going to get the tokenized text, and to get it, we're going to do tokenizer.tokenize of text, and we need to convert it to NumPy as well. And then we're also going to do dot lower, because if the letters or if the word is capitalized, then it doesn't really mean anything. We're just going to make everything lowercase to reduce the number of words in our vocabulary. Then we're going to do for word in tokenized text. We're going to do if word not in this frequencies dictionary, we're going to add it. So we're going to do frequencies of word. We're going to set that to 1. But if it is in our vocabulary, so else, we're going to do frequencies of word. We're going to add 1 to that. Then we're going to check if we've reached the threshold, right? That's the one we sent to the top here. So if frequencies of word is equal to some threshold, then we're going to do vocabulary.update and then tokenize text. All right. And then at the end of this, we're just going to return the vocabulary. All right. So quite a simple function. And we're just going to do that by sending in our DS train. So what we can do then is we can do vocabulary equals build vocabulary. So calling that function, and we're just going to send in DS train. Now, we might not want to do this every time because it might take some time to compute this. So what we can do then is we can do vocab file. We can open vocabulary.obg, and then we can do write bytes. We're going to do pickle. So we're going to use pickle. That's why we imported it. We're going to do pickle.dump vocabulary and then vocab file. All right. So this would build vocabulary and save it to vocabulary.obg. All right. So then if we've created it, maybe we want to have something for loading it. So we could do by vocab file is open vocabulary.object and then our RB for reading it. And then vocabulary is pickle.load that vocab file. All right. In this case, let's just uncomment that first of all. So we're just going to build the vocabulary and then we can save it if we want to run it at some other time. All right. So then we're going to create some encoder that can do the numericalizing, which is converting the tokenized string to indices. So we do that by encoder is tfds.features.text.TokenTextEncoder. And first of all, we're going to send in the list of the vocabulary. Then we're going to specify some end of vocabulary token. We're going to specify that to be the unknown. And those are going to be all the words that wasn't inside of our data set of a frequency of at least 200. Then we're going to do lowercase equals true. And we're also going to set in the tokenizer, which is just tokenizer in this case. All right. Then we're going to define my encoder. And what we get here is we're going to get some text tensor and we're going to get some label. And the first thing we're going to do is encoded text is just, we're going to use our encoder, right? This TokenTextEncoder to numericalize this text tensor that we send in. So we do that by encoder.encode, and we do text tensor.numpy, and then we're just going to return the encoded text, comma label. All right. Now, one thing we need to do in TensorFlow, which is a little bit unnecessarily complex perhaps, but we need to make sure that this Python function is a part of our computational graph. So we need to define another function. We're going to call it encode map function. We're going to send in a line right here, and that's going to be just the long line of the sort of the label, the review, and all of that we saw and printed before. So the first thing we're going to do is split line. We're going to do tf_strings.split line, comma separator, and then max split equals 4 again. Then we're going to get the label string. That's going to be the split line of index 2. So I'm not going to print the line again. Just believe me, this is index 2 of that. If we did the split, that's going to be index 2. So this is going to be negative or positive. And that is going to be that because we also removed all the ones that are unsupervised. Then the review is going to be, and we're going to add a start token right here in the beginning. We're going to add it with split line of index 4. So that's sort of the last one, which is going to be a long text string. And then we're going to, in the end, also add end of sentence token. All right, so this is our review, and this is going to then be sent to this TokenTextEncoder, which is going to be do the tokenization. It's going to do lowercase. It's going to then map it to some numerical values, and we can later send that into our model. So the label is going to be 1 if the label string is equal to positive. Otherwise, it's going to be 0 for negative. Encoded text, comma label is going to be equals to tf.py function. And we're going to do my encoder, the one we defined above. The input is going to be the review and also the label. Then we're going to need to specify the output. And the output in this case is going to be tf int 64 and then tf int 32. So this is for the sentence, the review, and this is going to be for the label, which is just going to be 0 or 1. Then the encoded text.set shape. This is something we need to do for the computational graph. We're going to set that to none in a list, and we're going to set it to none because the review length can be varied. A review could be just 500 characters, or it could be 100 characters. Or then we're going to do label.setShape, and we're just going to send in a list because it's only going to be one value. Then we're going to return the encoded text, and we're going to return the label as well. All right, so now we're sort of to a point where we have defined everything that we need to process our data, and we're just going to perform these mappings on the DS train and the DS test dataset. So first of all, we're going to do auto tune, and you're hopefully familiar with all of these steps right here from the TensorFlow dataset tutorial. So we're going to do tfdata.experimental.autotune. We're going to do dstrain equals dstrain.map. We're going to map it through that encode map function, and we're going to specify the number of parallel calls. And this is just this is just going to do them in parallel and make for faster data loading. And then we can call .cache as well. And this is going to cache some in memory to make it faster for the next run. So we need to do also a shuffle so that, as you saw, all of the examples are sort of negative and then positive, and we want to have randomized. So the data set is 25,000 in length for the training. So we're going to do shuffle 25,000. Now, perhaps 25,000 is a bit much. You could have done something like 5,000, but let's just do shuffle 25,000 to make sure it's completely random. Then we need to batch this. And remember, all of the reviews can be different in length. So we're going to need to do padding. And we do that by doing padded batch, specifying the batch size 32, and then we specify padded shapes. And on newer TensorFlow versions, you don't need to do this, but for older ones, I think before 2.2 perhaps, then you need to specify this. And we're going to specify none here because we don't know the review length. and then we're going to specify just an empty tuple, and that's going to be for the label, because it's only going to be an integer. Okay, so now that we have that, we can do the same thing for the test set, but we're not going to need to map it and shuffle it. So we can just do this right here, mapping it through the encode map function, and then padded batch 32, and again setting the shapes, which you shouldn't have to do this, but if you're using older versions, you might have to. So I'm just including it here. I'm going to do this quickly, and I'm going to create a model. We've actually done this exactly in the previous video. All right, so pretty quickly, we're just creating a very simple model, and we're actually just doing the embedding, and then we're doing a global average pooling across those embeddings, the outputs from those embeddings. And then we're just mapping that through a dense layer, and then output node for one single one. And then we're specifying binary cross entropy because we just have two classes with the Atom optimizer. All right, so hopefully there are no errors, and this should run. All right, and it doesn't. So let's see, text. All right, so we actually got there pretty early in this build vocabulary function. So let's see what we got wrong. Yeah, so here I wrote text.numpy. We should have the review, right? So we want to convert that to numpy. We want to make it lowercase, and then we want to tokenize the actual review. So hopefully, let's see if that runs. All right, so pretty amazingly, this actually ran. So what we can see is that we got, let's see, 97% after 15 epochs on the training, and then on the test set, we got 88%. But I mean, it doesn't really matter what performance we had. The important thing is that it actually works. So one thing is that when building the vocabulary, perhaps you could change it so that it just takes the, I don't know, top 1,000 words, and then you wouldn't have to set this threshold. And I think that should be pretty easy to implement as well. And as I said in the beginning, how this works is going to be different for every data set, because the structure is going to be different. So I want to give an example of also if you would have some kind of different structure. So let's see, I have a test example with 3 CSV files, and it's actually, let's see, it's actually the exact same. So let me bring it. It's also the IMDB dataset. It's just that we have a few examples on one file, we have a few examples on another file, and then we have another few examples on a third file. So what you can do in that scenario, if you have it split up into several CSV files, which might be very common in practice if you're working with large data sets, then let's do just I import sys and then sys.exit so it doesn't run the code below. Then what you could do is you could specify the file names. So in this case, that's test example1.csv, test example2.csv, and then test example3.csv. So what we could do is we could simply do dataset is tf data text line dataset of those file names, and it's going to work out all of. So it's going to be like you had them all in one CSV file, which is pretty amazing. So that is one thing you can do. We can just, to make sure that it works, we can just print line. And as you can see, it printed all of them, including the first one right here. And it's actually printing them for all of them. So maybe what you would want to do is remove this right here for those CSV files. But so that is one way that is quite convenient for the if you have multiple files. Now, one thing is that you might want to do different pre-processing on all of those CSV files. They might not be equally in structure like they were here. And then what you could do is you could specify just dataset1 is tf data text line dataset, and then we could do test example1.csv, and then let's do skip 1 just for the first row. But perhaps you would do something, in general, you would do .map and then pre-process 1 if you would have sort of different processing. So let's just copy that for all of them. So we're going to do 2, 3, 2, 3. And then to combine them, when you've now processed them differently, depending on the structure of those individual CSV file, you would do something like dataset is dataset1 dot concatenate, and then dataset2, and then concatenate dataset3. And in this way, we now obtain the entire dataset again. So if we do for line in dataset and then print that line, we get the entire dataset, which is including all of those 3 CSV files. All right, so that is if you would have, so this would be example if you have multiple files. And again, let's do import sys.exit. So let's say we had a kind of translation data set. So I'm actually going to create this ourselves. We're just going to do English, and then we're going to do Swedish. All right, so here we have them. We have English CSV, and then we have Swedish CSV. All right, so let's do language 1. And let's just do I love tuna, I love potato, I love bacon. Then we can do language 2 in Swedish. So you wouldn't be able to understand this probably. Jag älskar, what did we write? Tuna, tonfisk. Jag älskar potatis. Jag älskar bacon. So now we have those 3, right? So we have just 3 examples in this case. But how we would load them is we can, first of all, we can specify some tokenizer, as we did previously, which would be tfds.features.textTokenizer. Then we would do English is tf.data.textLineDataset, and we would have that English.csv. And then for the Swedish, we would have tf.data.textLineDataset Swedish.csv. And then what you could do is you can do ds or dataset is tf.data.dataset.zip, and then you can do English and then Swedish. So now we could do for English and Swedish in dataset, and then we can just skip the first row again. Then we could do something like print tokenizer.tokenize English.numpy, and then we could do tokenizer.tokenize Swedish.numpy, and then we need to also do decode to UTF-8 because we used special characters. So special characters would be something like this right here. So that's just why we're doing decode UTF-8. But let's run that and just see how it looks like. And then we can see that it's splitting those examples that we had, this is one pair, right? This is the translation of this first one. And what you would need to do then is you would need to do first of all, you need a vocabulary, and then you would need for each language. Then you would need to do tokenize and numericalize words. And so this is hopefully what I've shown you how to do. So you would be relatively confident that you can be able to do those 2. And then we need to do padded batch to get batches and so on. And then we also need to, create a model. So create model. And the model in this case is probably something like a sequence-to-sequence model that might be a bit too advanced for you to implement, or it could even be a transformer network. And I haven't covered any of those because I think they're a little bit too advanced and is beyond this video. So what we wanted to focus on in this video, which hopefully has been as clear as I can make it, is how you would load custom data sets for text using this TextLineDataset. And hopefully I've also shown you some different ways depending on how your dataset is structured. So I've said this before, no dataset is exactly the same. All of the data is going to be differently structured. So how you load it is going to depend on your dataset. But hopefully you've learned some principles of sort of the general pattern of how you should load the data. that you can apply to your own project. So that's it for this video. Hopefully you found the video useful. Thank you so much for watching, and I hope to see you in the next video.